start graphing rational inequalities. So again, we always want to have 0 on the right-hand side. We want to make sure your rational fraction is just one fraction. And if it's not in factored form like this one is, we'll have to factor it. So everything's ready to go. So what we're going to do is we're going to count the number of our linear factors. There's 1, 2, 3, so we'll need 3 tick marks. Then we're going to remember, and this is what you're going to see a lot in the homework, you'll see a lot of equal to lines. Remember, x cannot be equal to 1. So this is going to have to be an open circle from the bottom factors, but the top will be closed factors because those are your x-intercepts. This is your vertical asymptote. Remember when we made the graphs, the vertical asymptote was an open circle, x-intercepts were closed. So that same concept is going to be back here. Then they're all positive x's. So right-hand behavior is positive. Then they alternate because each factor occurs once. Put open circle for the one on the bottom. The 3 and the -2, those will be closed circles. We wanted to shade the negative region, so shade negative. And now correspond that to interval notation, -∞ to -2, with a bracket union open circle, so left parentheses 1, comma 3, bracket. Next example, it's greater than or equal to 0, so whoops, we got some factoring to do here, x squared minus 1. So we'll factor that. That's a difference of perfect squares, so x plus 1, x minus 1. And on the top, we have 2x minus 2 binomials, so I'm writing them out twice. So I see x equals 2 twice on the top, x equals plus or minus 1 on the bottom. Remember, these are going to be open circles. Good idea to maybe put an open here, close that circle on the top. We want positive regions, and so we're going to put our tick marks. We have 4 binomials, so we're going to put in 4 tick marks. We're going to take care of our right-hand behavior. They're all positive x's. So positive x on the right, alternate going to the left. Put in your numbers, and just like we had before when we had the 1 was listed twice, we're going to go -1, 1, 2, and 2. The -1 and 1, these two are open circles. The 2 2's are going to be closed circles. We want to shade positive regions, so from here to the right, in between the 1 and the 2, and from the -1 to the left. Now, we'll go ahead and put this in interval, wait a minute, interval notation. If this is equal to 2 here, and this is equal to 2, there's really nothing between the 2 2's. Now, when we had the previous problem, those were open circles, so we had to keep those. Here, you can literally slide this tick mark of 2 over to the left. So we're going to squeeze that negative area out. And so now your interval notation is -∞ to -1, union 1 to +∞, all parentheses, no brackets because the 2's were the same. Now, if this was an open circle right here, there would be a break or a gap. So when I had the 2 1's with open circles, I didn't squeeze it together because they were open circles. We just left it. All right, the next problem here, now it's a little different. Notice there's no 0 here. So before we can get this started, we need to have 0 on the right side, so I'm going to subtract over the 1. Now, we have to have one fraction. So we're going to take that 1 and multiply by 2x plus 4 to the top and the bottom. And that way we're going to combine like terms. So this -1 has to be distributed into the top. So -2x, -4, combine like terms. We're going to get, a -x with a -8. On the bottom is our 2x plus 4 greater than or equal to 0. So here, solve this for x, set it equal to 0. X is equal to a -8. On the bottom, subtract over the 4, divide by 2. X is equal to a -2. But this is open, this is closed because we have the equal to line. So we need 2 tick marks. -8 will be closed. -2 will be open. But in this case, just want to point this out before we go any further. Now this x is negative. This x term is positive. So a negative divided by a positive. Right-hand behavior is now negative, then positive, then negative. So now I put in my circles. Some people will tell you to always graph the open circle first. As you've seen earlier, it really doesn't matter. So here we want the positive region, shade in between. So we're at -8 to -2. -8 gets the bracket, -2 gets the parentheses, and there's my answer. Next example. Whoa, now we have 2 fractions. We still need to have a 0 on the right side. Subtract over the fraction. But in order to combine these 2 fractions together, we have to have a common denominator. And right now, these 2 denominators on the bottom are going to be my LCD. So this fraction gets multiplied by the second denominator, both top and bottom, x plus 1, x plus 1. The second fraction gets multiplied by x minus 3, top and bottom. So now we have common denominators, but be careful here. You're not distributing a 3. Remember, you got to distribute the -3. So you're going to have 5x plus 5, and then -3 times x is -3x, and -3 times -3 is a +9. Combine like terms, 5x minus 3x is 2x, 5 plus 9 is 14. So solving the top, subtract 14, divide by 2, x equals -7. Equal to line, so this will be a closed circle. X equals -1, x equals 3 on the bottom. These will be open circles. And we still want to shade positive regions. So we need 3 tick marks. -7, -1, 3. It's a positive 2x, a positive x, and a positive x. All 3 are positive, so the right region is positive. And then we're alternating our signs to the left. -7 is going to be closed. -1 and the 3 will be open. Shade your positive regions. And then build your interval notation. Bracket -7, comma -1, parentheses, union parentheses 3 to positive infinity. And our last example, we have our 0, but we have something a little bit different here. There is an x squared plus 1 here. So when we factor, we can only factor the bottom. Now, so the author again, and this is optional, you can do this, you don't have to do it. If you want to factor out the -1 here, you can. The author will suggest it. As we saw earlier, we had a -x. It doesn't matter. So to get rid of the -1, you have to basically multiply both sides by -1 or divide both sides by -1. So that flips your inequality symbol. Remember, we talked about that when our leading term and our polynomials were negative. And now notice that the x squared plus 1, when we start to find our answers for x, that will never be equal to 0. So therefore, this does not generate any x-intercepts. So cancel it out. We don't need it. So on the top, you're going to have x equals 0, x equals 2. On the bottom, x equals -1, x equals +1. Closed circles on the top, open circles on the bottom. Again, we still want the positive region. We need 4 tick marks. Numerical order, -1, 0, 1, 2. Again, take care of those open circles probably first after you put in your signs. Again, the order in which you do these don't matter. You can do the circles first, then the signs. But our right-hand behavior is positive, 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 positive. Even your x squared was positive. And then alternate going to the left. So as we said, -1 and 1 were the open circles. 0 and 2 were the closed circles. We want the positive region. Shade the positives and build your interval notation. -infinity to -1 with parentheses, union, bracket 0 to 1, parentheses, union, bracket 2 to positive infinity. Now again, as I mentioned earlier, you could have left the minus here. You could scratch out the x squared plus 1 like we did down here. You could still solve this. You're still going to get 0. You're still going to get 2, -1 and 1. But your right-hand behavior would be a negative, then a positive, negative, positive, negative. And if it's less than 0, you want negative answers, so you still shade the same areas because we just said negative, positive, negative, positive, negative if you left this as a negative. So you still shade the same regions. With that thought, I very rarely worry about factoring out a -1. I just want to get to my setup of my number line, my circles, my regions shaded, and write my answer. Okay, and that's the last of 5.6.